folks. We're going to keep it cruising. But, let's keep it light. Let's keep it fun. I've got this guy. He keeps commandeering the sessions. And speaking of sessions, I found out who the winner was of those headphones. Let me get their exact name, and I will make sure to give you these headphones. Here it is. The winner, after long, well, not that long, deliberation, is Rutvik Balerau. Sorry for the mispronunciation if that is your name, because I get the feeling I did not pronounce it correctly, but you win. Hit me up. Send me a DM. Congratulations. Fear not if you were not the winner, because we've got 2 more pairs of headphones that were given out. Also, Rudvik and whoever is a future winner, let me know if you want the AirPod Maxes or you want the Bose. I myself would go with the Bose, but that's why we give you a choice. Next up, we are going to be bringing on Binwei. Where you at, man? Hey, there he is. How you doing?
Good. How are you?
I'm good. I'm ready for your talk. I'm going to let you get rocking and rolling because I ate into your talk time by sharing the winners of the giveaway. But as I mentioned, at our next break, we're going to be giving away more headphones. Now, the floor is yours. I'm going to share your screen and let's hear what you got about gluten.
Yeah. Okay. Hello, everyone, and welcome to join the session. And today I will share the Apache Gluten project. So today I will focus on the lake house support in the Apache Gluten. And I'm Binwei Yang. I'm from IBM, and we have a GitHub. So in some, of course, it's an Apache project, and also we have a LinkedIn, and also we have a Slack, SF on SF workspace, and also we have the workspace, which have workspace. So today I will cover several topics. Firstly, it's a simple introduction, and then some performance data of the gluten and the latest performance data, and then I will focus on the house support. And then finally, we will have a Q&A. So firstly, the gluten itself, gluten is an Apache plugin. It's an Apache Spark plugin. So it's run on top of the Spark. It's a Spark plugin. So what happens is that we use the Spark controller as much as possible, and we just offload the compute-intensive work operators to the native library. So if you have a Spark workload, you have a driver node, you have a work node. In this work node, you have several executors. And in this executor, you have one or more task thread. And in each task thread, what happens is that we check if this operator is supported by the native library or not. If it's already supported by native library, then we offload it to the native library through a GNI. If it's not supported, then we fall back to vanilla Spark sequence. So in this way, we can run the circle operators or the circle queries to the native library if it's supported. Otherwise, we just fall back to vanilla Spark. So the gluten itself doesn't need any extra hardware or the dependency libraries, because that we already packed all the dependency libraries in a third-party jar, and we can distribute the third-party jar from the gluten from Spark itself. Also, we have a way to build a gluten library in a static way. So in that way, all the dependency libraries are already linked into the gluten libgluten SO. And in that way, you needn't to install any third-party libraries on your work node. So the dependency library is very minimal if we use a static link way. In that way, you can use a single jar to distribute the gluten to each work node, and it works. So you needn't to install any libraries on your work node. So it's also, of course, it's transparent to the Spark workload. So you needn't to modify any Spark circles. You just need to configure gluten in the Spark configs and then run the gluten. So currently, in gluten, we have two backends actually. One is the Velox. We worked with Facebook on this, Facebook Velox, and another one is the ClearHouse backend. ClearHouse backend is developed by Cligence, so another company. And also we use Apache Arrow computer engine as well in gluten in the to compute to work with the Velox together. Also, we can easily support the third-party engines. And this is the current performance boost ratio. And on TPCH, we can boost three times performance better. And on TPCDS, like the workload, we can have 3.35 times. And the update size is as of 500, and the instance is 4x6 ID to 0x large instance. So all the Docker files and the computation analysis script is already upstreamed, so everyone can try that. So you can try on single node SF100 or SF500 on 4 nodes. So you can get it really so easily. And here, I want to highlight is that different partition number is configured between the vanilla Spark and the gluten. So we can make sure that there is no spill in vanilla Spark and the gluten both. It's because that the gluten uses much less memory if we run a query. So in that the vanilla Spark consumes more memory. We need to configure larger partition number. In gluten, we can configure small partition number. And this is the current gluten roadmap in 2025. I wanted to highlight is that we will focus on the house support mostly. First, in Q1, we already passed the Iceberg UT. So we ported Iceberg Spark UT to gluten, and we passed all the Iceberg UTs. But not all Iceberg features are supported in gluten today. So some of the Iceberg features are fallback to vanilla Spark. So it uses Java Iceberg and the Spark Iceberg. And but we correctly fallback the rules, and also we offloaded the rule we already supported. Now we already support the basic party writer, basic Iceberg reader, but we are working on the Iceberg writer now, and we will end the Iceberg writer support in Q3. It's planned in Q3, so offload the writer to Iceberg to Velox. And meanwhile, we will also end the Hoodie Spark support and the data lake Spark. Currently, we already support the Hoodie and the data lake, but the UT is not passed. We didn't port the UT to Iceberg, so we don't know how many cases if the Hoodie can support or correctly fallback or there is some issues. So the UT is not. It's just the basic Spark, basic reader is supported in Hoodie and in gluten for the Hoodie and the data lake. And in Q3, we will port the UTs. So once we pass the UT, we can make sure that it's somehow already stable enough for the customer can try. And of course, currently, the customer, there are lots of the gluten customers, they already tried the Hoodie Iceberg, they already use the Hoodie Iceberg today, and just for their workload. So in their scenario, they can pass, so they can use the that. But overall, the Hoodie UT is not passed yet. In Q3, we pass that. And also, we only support the Hoodie read and the data lake read now. And in Q4, we will end the Hoodie data lake write. So we will use a similar way over Iceberg to end the Hoodie and the data lake write support. So there are a couple of, in this year, we will put more effort on the data lake support. It's because the customer really are moving from Hive to Iceberg and the Hoodie data lake. So we need to understand support. And for the other part, we also will work on some of the GPU support now. So the NVIDIA guys worked with the Velox and the UDF support in Velox, and we will use their accelerators in Velox and offload it to the GPU in gluten. So there are some other part we can know. And the Iceberg support in gluten today. So what happened is that we already supported Iceberg Reader and Iceberg Writer, but it's supported in different way. For Iceberg Reader, it's part of the Velox pipeline today. We implemented all the Iceberg Reader in the Velox and in the C++ in Velox, and so we can easily pass. pass the whole query plan, including the table scan and all the other operators in the same subject plan to Velox, send to Velox, and Velox can start the whole pipeline from the table scan to the other operators. And for the Iceberg writer, it's implemented different way because then we reuse the Iceberg Spark writer Java code. And as much as possible, we just offload the packet writer from Iceberg writer to Velox. So if it's the whole packet writer itself is offloaded to Velox, but the operator itself is in Spark JVM. So we rewrite. It's not exactly the same packet writer support, the table writer support in Iceberg. We rewrite it, but we use lots of Iceberg Java features here, and including the commit features. And when the data is read to Iceberg, what happens is that we get the columnar data pointer from Velox after the last operators. Like if it's a join or has we get it from Velox. It's a data pointer. It's not the data itself. And we send the data pointer to Spark. And the Spark started the next operator, started Iceberg write operator. It's customized operator. And then the operator take the data pointer and pass it to a Velox packet writer. And then the packet writer will use the data, then write it to the packet files, and return the metadata to the Iceberg writer operator, and then the Iceberg write operator will handle the rest, like the commit will handle everything else. So there is no data copy, there is no data movement between the off heap and the on heap, or between the native and the JVM. So it's just the pointer passed through the Spark. So this is how we supported Iceberg read and write today. But we have the gluten itself is designed very flexible. So as long as the native engine native library can support the Unreal, can use the Unreal data format and can support the substrate plan, we can easily offload to different libraries, just like I showed in the CleanHouse or Velox. So here we didn't implement the Hoodie write in Iceberg. So what we are planning now is that we reuse the Hoodie Rust. And because Hoodie Rust, currently the Hoodie Rust doesn't support write yet, but if it is supported, then we can use the Hoodie Rust directly, and we can offload the Hoodie write from gluten to the Hoodie Rust directly. What happens is that we get similarly we get the Iceberg, we get the Hoodie, get the data pointer, and then from Velox, and then we will need Velox to Unreal conversion. So Velox and Unreal data format are compatible. Mostly are compatible. So there's no data copy there. It's just a example from Velox to Unreal. And then once we convert the data format to convert the data wrapper from Velox to Unreal, then we send the Unreal data set to Hoodie Rust, and then the Hoodie Rust get the Unreal data and then complete the Hoodie write here. So we can implement it easily. So the benefit is that we needn't implement everything in Velox. We can reuse the Hoodie Rust. We can reuse the data lake or anything. So and we can reuse, and we can get a better performance than the Java version. So we can reuse that. So it's the flexibility of the gluten and the gluten. And furtherly, we can also push down the filter or the hash aggregate to the storage. So it's another flexibility with the gluten. So currently, if we already have a substrate plan and we have some filter, and the filter can fit most of the data, then we can have a way to push down the filter and the gluten to the filter and the table scan to the storage layer. So here we can use in the storage layer, we can use the Unreal library or Velox library, or even currently we worked with Google Data Park to their BigQuery directly. So in that way, we can filter the data under the storage layer and on the storage node, and then return the data on the Unreal format. And then we get the data on the work node, the computation node, and then we convert the Unreal data to Velox and feed it into the Velox pipeline. Again, there is no data copy, there is no mem copy there. So it's just an example from the Unreal format to the Velox format. and then feed into the Velox pipeline to take the rest of the operator, to take the rest of the, to run the rest of operators. So this is how the gluten we can support now, and the Bitcoin already passed, so the Bitcoin they already use, but the Bitcoin didn't use the substrate plan. Currently, they still use the part of the circle and convert the cut part of the circle and send it to the Bitcoin and get the data, and then return the data to Spark pipeline, and then we get the annual fermenter. I get the annual data pointer, and then feed into the annual pointer to the Velox. So the whole pipeline is already passed. Similarly, we can use the Iceberg, or we can use the Hoodie, or we can in future we can use anything. So just open the API from the Iceberg, then push down the to the substrate to the storage layer, and complete the filter there. So this is even the future design. And when we worked on the gluten and the fast, so we see lots of opportunities. So it's generally the metadata requirement from the gluten to boost the performance. For example, the first one is the partition number. The partition number is essential to the gluten because then for the smaller partition, the gluten runs very fast. So if the partition is very small, then the Spark overhead, the scheduling, and all the other Spark overhead will be much more than the native library time. So in that way, you cannot see the performance boost. You can just say that every day, all the time are spending on your Spark. So the partition number is really, we need a large partition size for each data, and also because then the gluten can use much less memory than the Spark. In that way, we can input even larger partitions, partition size, and then we can get much better performance. And the other example is that the hot columns. So currently, the Velox already support the cache in local SSD, so it can cache the root group in local SSD. But what we don't know is that which column are the hot columns, so we should cache. Currently, we can count that in Velox, of course, but I think that it makes more sense that we can get this data. If we run the queries, we get this data and save it in the meta store and save it in the lakehouse, like the Iceberg, and then we can get this in next query. We can get this information from the Iceberg and then cache it in the local SSD, get the local SSD cache. And another one is the characteristic of the columnar data. For example, currently we support the dictionary shuffle. So it's a unique feature in columnar shuffle because then in this way we can shuffle every column one by one, and then we can create a dictionary for each column. And then we have an issue is that if this column is dictionary friendly or not, we don't know that. Currently we use a way that we check the first record bunch and see if the first record bunch is dictionary friendly or not, then we use it. But if we can get such information from Iceberg or from Hoodie, then that will be very useful for us to input it and then to use a dictionary for this column. So it may be derived from some initial dictionaries. So we need to record that. And the other one is that in the native Velox library, we needed to pre-allocate the memory for the columnar data on lots of times. So in that way, we needed to relocate the memory. If relocate means mostly means a mem copy. Yeah. So if you relocate the memory a lot, then the performance is the time is spending in the mem copy mostly. So if we know the average length of these strings in advance, then we can use this information to pre-allocate the memory in some operators like the hash like the hash aggregate. We can preload the memory in this, also in a shuffle. In that way, we can get a much better performance. So currently, it's we use a similar way that we pass the first record bunch and get the average length of the string, and then we use that number to pre-allocate the memory. But of course, it's not instant. And the other example is that the root group was split. The Velox itself supported the background IO, and it can read hide the root group, read hide over the split. But now there is an issue that we don't know. Because before we pass the packet file, we don't know if the root group, if this split has one or more root group, we don't know that information. And also we don't know if we have, we can know there are several split, one or more split, but we don't know if we need to read hide over this next split. So this information, if we can get this information in advance, then we can input that in the dialogues and get back the multiply it. So currently we have to rely on the customer to configure the read hide of the group, configure read hide of the split. So it's customer responsibility now. But if we can get such information from Movida stuff, we can get. So this is just an example. So if we use Iceberg more and more, and we use the customer workload, we will know more. So some of this, like the local cache, is already supported in Iceberg, but we need some way to get that information and feed into the dialogues libraries. So this is the gluten root house. Okay, that's all. So again, we have the link here, and we have the SF Slack channel here, and we have the group here. So welcome to join, and welcome to try the gluten and send us the issues in the GitHub or Slack channel. Okay, any questions we can answer now?
Oh, there are questions. I'll let some trickle in. I'm going to kick off one because this platform is very robust, I think, is the best way that I can explain it. I am assuming the journey from zero to hero here took quite a bit of time. What are some opinions that you took along the way that you are now thinking about updating?
So we have lots of features here, and we need to implement. And I think that so it's a customer support. So if more and more customers use the gluten, then they will raise the issues, they will see the bugs, and then they ping us, and then we fix them. Initially, we fix most of them, and taking time, the customers themselves, they become more and more familiar with the gluten project, and then they can fix the bugs by themselves, and then they can make the gluten more robust, more and more robust. So I think that it's a general that how the gluten community grew. Actually, it's not the gluten project itself. It's how the community grew. So if the customer if more bugs are fixed, then it's more robust. Yeah. So I really appreciate that the customers, there are most of the Chinese companies who have the Spark cards, they already tried or already landed the gluten, and they already use the gluten in their business platform today. And then they can, they fix a lot of the bugs for us.
Excellent. Next up, Pedro's asking, how hard is it to migrate existing Spark workloads to gluten? Is it plug and play, or is there some migration effort?
It's a plug and play. So you just need to configure the Spark jar and into the Spark plugin and start and configure. There are several essential configs. It's documented in the gluten on GitHub link. And once you configure that, then you can get the gluten going.
Well, that sounds nice. All right, I like it. This has been incredible. I have to keep an eye on the time because we are rocking into the third break. I want to thank you very much for giving this talk and sharing all about gluten. I'm sure there is a joke in there somewhere about how some people are gluten-free or celiacs. You probably make that joke quite a bit.
Yes. Yes.
But I appreciate this, Binwei. Thank you so much.
Thank you. Thank you.
Rocking and rolling, and I will see